Hello folks, this is Mr. Messman with the Flipped Classroom vodcast. MOW number 14, I can observe and outline the geologic history of the Missoula Valley. And here's a picture of the Missoula Valley where we're going to go hiking on Mount Jumbo. Let's start with an overview of the geology of Missoula, shown here on a USGS overlay on Google Earth of the rock units around Missoula. Let's start with the youngest. The youngest are the yellow, which are called Quaternary alluvium, which is modern stream sediments, basically stream gravels and clays from the rivers. The darker sort of brown is glacial deposits from the ice ages. The gray is valley fill from the desert times, when our valleys filled with sediments. And the green, the red is igneous intrusions, and the green is the belt supergroup rocks. Now I'm going to show you a couple illustrations from Roadside Geology to Montana by Alt and Hindeman, such as this one. Let's talk about the belt supergroup. These rocks formed in Montana and Idaho 1.2 billion years ago. Okay, and we'll talk a little more about those in a minute. Next, after the belt, is the Rocky Mountains. Okay, and our part of the Rocky Mountains were formed when a large slab of rock slid off and created the Bitterroot Valley, shown here, BV. This slab of rock is called the Sapphire thrust block, outlined here. We are going to take our field trip right on the northwest corner of the Sapphire block, and the rocks there are going to show some signs that they've been crunched up as this Sapphire block slid eastward off of the Bitterroot Mountains in the Idaho batholith. Now this drawing here shows the rocks that have been folded by this movement. Here are some that we're not going to see, but they're standing straight up over by Bonner. Okay. Next, let's talk about the desert times. Here is a screenshot from southern Nevada, where the valleys are all full of sediments that are washing onto the valley floor in a desert. If you look at this picture of Missoula, you can kind of see the same thing with some of the rocks on the edges of the valley. And I'll point those out to you on the field trip. Here's a cross-section of those sediments called the Renova Formation and the 6 Mile Creek Formation. Finally, we get to the ice ages in Glacial Lake Missoula. This little animation shows the ice sheets that came down from Canada, only the U.S. portion. They blocked up the Clark Fork River, creating Glacial Lake Missoula. And then Glacial Lake Missoula drained to create the channeled scablands and flowed all the way to the Pacific. All right, here's the overview. First, Precambrian belt supergroup rocks that we'll see on the field trip. These rocks are 1.2 billion years old and formed in the Belt Sea that occurred in this area of North America 1.2 billion years ago. In places, they are almost 3 miles thick. Number 2, the Rocky Mountains. About 100 million years ago to about 50 million years ago, this part of the continent was compressed from the west as the Pacific Plate dived under North America. And this created folds and thrust faults. And part of that mountain building was the Sapphire block that slid off the Idaho batholith and crumpled up the mountains north of Missoula, north and east of Missoula. Number 3. Time of extension began about 50 million years ago, and that includes Mount Sentinel, the Mount Sentinel Fault and Mount Jumbo Fault that we'll be pretty much walking right over. That was about 50 million years ago, and continues today with the Mission Fault. Number 4, the desert times, when the valleys filled with sediment, like we see in Nevada, because there were no rivers to carry them away. And finally, the Ice Ages, number 5, starting about 2.5 million years ago, and the modern streams, like the Clark Fork, began to flow. Thanks for watching.
That's a wrap.